MacMaths, let's do some maths today. Okay, welcome back. This is essentially going to be lesson 7 in our trig series at AS Maths, and actually going to be the last lesson in the series. We're looking at harder questions again today. This is part 2, I did a part 1. Today we're going to specifically be looking at quadratic style. You can see the shape of my first 2 examples there. We've got the quadratic in here. And I'm going to also be looking at a special case. If you've got to see this really to believe it, not really. You've got to see it to sort of know how to do it. So I'm going to finish on this special case here, not so obvious. I'm going to go through about 4 examples. We're just going to solve them the same way as just show you that they're actually the same as a normal quadratic equation. And these are a favourite really, of the exam. The example. So these are the ones that you usually get at AS level when you are solving equations, trig equations that is. Okay. I'm going to go through this first one. Okay, so 9 tan squared minus 4 is equal to 0. I want you to compare that with, 9x squared minus 4 is equal to 0. It's just a normal quadratic, isn't it? We could just solve this 2 ways, okay? We could solve it by going 9x squared is equal to 4, divide by 9, both sides. So you've got 4/9. Okay, so I've added 4 to both sides, and I've got that, and then a square root, and when you square root both sides, I chose these numbers on purpose. Look, square root this, 4's a square number, 9's a square number, so it square roots to 2/3. But we do have to remember, don't we, that it's plus or minus. Okay, so x is plus or minus 2/3. Of course, it's not x, is it? We swapped tan for x, so instead of being x now, it's tan x or tan theta if you want, same thing. Okay. Another way I did say there was 2 ways of doing it. Okay, if you divide through by 9, we've got, I'll do it in red, I'll stick with red. We've got x squared minus 4/9, haven't we, is equal to 0. And because this is a square number, we can factorise, and we do encourage you at GCSE, don't we, to, when you see the shape of this, that a squared minus b squared, it factorises, doesn't it? It factorises to a plus b times a minus b. And this is one of those. It's, it's x plus 2/3 times x minus 2/3, isn't it? Okay, is equal to 0. So x is 2/3, x is minus 2/3, or x is plus 2/3, the 2 values that we've got. Just very quickly finish this off. What would we do next here to solve this bit, okay, to get our solutions? Well, I'm saying that all of these that I'm going to go through today, we'll just do for ease, we'll do theta or x between 0 and 360 degrees. So we're looking for solutions between 0 and 360. That is very common. If we're doing this, we just inverse tan both sides. First of all, just looking at the positive 2/3, inverse tan of 2/3 would give you 33.7 degrees. That's your acute angle. That's what it would give you. And of course, tan is positive in this region as well. So that, for tan, for positive 2/3, it's the same as this one here, which is 213.7 degrees. But we've also got the negative version of 2/3. Okay, so let's rub that plus out. We've got inverse minus 2/3. Of course, we just want to go 33.7 into this region and 33.7 into this one. So take it off 180 would give us 146.3, and take it off 360 and that would give us 326.3, I believe. Okay, so that would be the solution to tan of x is plus or minus 2/3. 2 solutions for plus 2/3 and 2 solutions for minus 2/3, and they're all actually 33.7 degrees turned into all quadrants. Okay, so that's that first one solved, just a very sort of straightforward one. But the ones that you're going to see more of, and certainly the ones that they will test you on in the exam, let's get rid of that one now. Are ones like this one here. Let's just get rid of these values so we can use this cast wheel again. Okay, so I want you to look at this one. I've not made it so straightforward. You can see the shape of it. we can compare that, can't we, with 2x squared plus 3x is equal to 2. You're told, aren't you, with quadratics to get everything over to one side and equal to naught. You know, when you've got it in this form, this ax squared plus bx plus c equals naught. Okay, so let's do that. Let's take it over. So we've got 2 sine squared x plus 3 sine x. Take 2 off both sides, and now it looks like the quadratic that we're more used to. Yeah, okay, and again, I'm just doing this side by side with how you've seen them at GCSE. Go into 2 brackets, okay? That's, of course, if it goes into 2 brackets, this is A level, so this might not factorise, you know, it might be one that you have to use the quadratic formula, minus b plus minus the square root of b squared minus 4ac all over 2a. You may have to use that formula, you know? It's not a big ask, is it? Okay, so 2 sine x and sine x there, okay? And we've got to make minus 2, so it's going to be 2 and 1, isn't it? We just got to decide where to put the minuses. We want a plus 3 sine x, so let's put a plus there and a minus there. Yeah, that's going to work, isn't it? Okay, so this would be 2x and x, okay, and we've got a plus 2 there and a minus 1. So GCSE, AS level, okay? You can see we're doing exactly the same thing. This one, where this is equal to 0, well, look at where this is equal to 0. It's equal to 0 where x is equal to a half, isn't it? Put it that equal to 0 and solve it. And this is where x is equal to minus 2. Same with this one, but it's not x, it's actually sine x is equal to a half, and sine x is equal to minus 2. So this is our GCSE version, and this is our A-level version. You can see that we've done exactly the same thing as what you've been taught at GCSE. The one step further, of course, here is, you know, is that understanding. That's what makes it A-level, that we're looking for solutions for these two here, and we're looking for solutions within a range of 0 to 360 in this case, because that's what I've chosen. Okay, this is our old friend, exact value, isn't it? That's 30 degrees. It's positive, so it's 30 degrees. So 30 degrees into here, but also for sine, it's positive here, so that's 30 and 150, isn't it? So x is going to be equal to 30 degrees and 150 degrees. There we go. We've solved that side. This side, okay, sine x is equal to minus 2. Forget the minus, but if you inverse sine of 2 on your calculator, or indeed minus 2, you'll get an error. And there's the sine graph, and you can see why. Because sine only goes up to 1 and down to minus 1. So there's only values between the ranges of 1 and minus 1. Okay, so minus 2 is down here, and our sine graph doesn't cross that line, so there are no solutions. So, you know, you just put a cross underneath that. That particular, on this occasion, that does not give you any solutions. Okay, so the only two solutions for this quadratic that lie between 0 and 360 degrees is 30 degrees and 150 degrees. Okay, so there we go. There we have it, a quadratic. However, I'm going to go through what they're going to give you at exam level now, because they're probably not going to make it that straightforward for you, because they can actually make you do an extra step, and that extra step, that is what they make you do. Okay, so when you see exam questions, they're going to look more like this that I'm going to show you now. So this is my EG3, okay? And before I start the EG3, what I'm going to do is I'm going to tell you how they set up a question at A level. They're going to set up a question where they will mix a cos squared x with a sine x, or they will mix a sine squared x with a cos x. Okay, so here what you can't do is, well, you can, but not that would help you solve. It's very difficult to change a sine x into a cos x, okay, and it's difficult to change a cos x into a sine x. You can't do it algebraically, but you can change a cos squared x into sine squared x algebraically using the identity sine squared x plus cos squared x is equal to 1. Okay, and my 1 looks like a 7 there, doesn't it? Okay, so that is what they're going to give you on the exam. Okay, so they're going to give you a mixture of a cos squared and a sine x, or a sine squared and a cos x. And whichever one you get of those, always change your squared. Change your sine squared into 1 minus cos squared. Remember rearranging this, or your cos squared into 1 minus sine squared. Okay, so let's have a look at an example then. So if I give you the example, I wrote one down, so I've got that just out of your sight. 2 cos squared x minus 5 sine x minus 4 is equal to 0. Okay, so there's my example. I've done this one as well, that I've done it so it works out nice. It's one that factorizes. I don't need to use the quadratic formula on it, just so it's quicker and easier when I go through it. Okay. In this form, you can't do anything with this because, you know, we can't have a sine x with a cos squared x. You know, before you saw me do a substitution, well, you know, I substituted in another letter. I chose y, didn't I, for sine x. Doesn't cut it for cos squared x. Okay. So remember what I said, we're going to change this. So we're going to change this cos squared into 1 minus sine squared x. From the identity, isn't it? That's the other rearrangement of the identity. Sine squared plus cos squared equals 1. That's probably another subscriber. That's my phone there. Okay. So if we change that, okay, multiply it out, 2 minus 2 sine squared x minus 5 sine x minus 4 is equal to 0. Now you can see we're getting there, aren't we? We've got sine squared and sine x. Just need to tidy up. Our 2 and minus 4 is minus 2, isn't it? So we've got minus 2 sine squared x minus 5 sine x minus 2 is equal to 0. Multiply through by minus 1, or take everything over to the other side, and we've got 2 sine squared x plus 5 sine x plus 2 is equal to 0. Okay, and if we factorise that, I won't change it to y this time, I'll just call it 2 sine x and sine x. I'm going to stick my 2 there and a 1 there. They're both positive in this case, you can see. 2 sine x times sine x, 2 sine squared x, yep, plus 4 sine x plus 1 sine x. 4 sine x and 1 sine x is 5 sine x, and 1 times 2 is 2. Factorise, okay, we factorised it, sorry. Solve it, so in this case sine x is equal to minus a half, and this one sine x is equal to minus 2. Okay, if it was a normal quadratic, there's your answer, but it's a trig quadratic, isn't it? Minus a half, remember, cover that up, inverse sine a half is 30 degrees. That's our exact value, 30 degrees. I hope that you're starting to learn that now. But actually, the minus means it's not in the sine region, the all or the sine region. You know, it's in this region here, isn't it? Okay, it's 30 degrees into this region, so back from 360, 330, and 30 degrees into this one here is 210 degrees. So it's these two values here that we want for sine of minus a half. That's 210 degrees and 330 degrees. And likewise, this one, like with the other one, you know, sine does not go down to minus 2. There's no solution to that. So in this case, this is what you're going to see at AS A level. Okay, you're going to see a mixture of cos squared and sine, or sine squared and cos. You always use the identity of 1 minus sine squared or 1 minus cos squared for the other one. Okay, and you solve it this way. When you get down to this stage, don't expect always to be able to factorise it. We may have to use the quadratic formula with A as 2, B as 5 and C as 2. just bang it into the formula, okay, and at the end when you get your two values, remember they're not x equals now, they would be, in this case, sine x equals, and then you inverse sine it, okay? So I hope that is clear. I'm just going to finish on one special case now, okay? You're going to come across this and you need to have seen it before, okay, because it will throw you otherwise, okay? I'm going to do my best attempt to explain this to you, EG4, and it's going to be hidden as well, so it may not be as obvious as what I'm doing now. So there may be some rearranging to get to the point where I'm going to start from today. And I'm going to look at this one here, sine x cos x plus sine x is equal to naught, okay? I want you to be really careful with this one. Unless you've seen it before, you might not recognise it as a quadratic because it doesn't look like a quadratic. You can't see the squared. Remember that sine and cos are actually the same curve. One's just that one is a translation of the other. So this sine x times cos x is really like a squared. So I want you to compare this to, not exactly, but I want you to compare it to this, x squared plus x is equal to 0. Okay, I'll just look at this one for a moment. I'm going to do this the wrong way. The wrong way of doing this is to divide through by x. It's tempting, okay, but it's the wrong thing to do, because if we divide through by x, it sort of works. We get x plus 1 is equal to naught, okay? So we've divided through by x, everything by x, and we get this, okay? And we get the solution of x is equal to -1. And that is a solution, it's a correct answer to this. But you're taught that if you do that, you miss out a solution, okay? And what we've missed out by dividing through by x is we've missed out the solution x equals naught. Because what you're taught is, you're taught, or we try to teach you to factorise these rather than divide through. Because if you factorise it, you get x plus 1 is equal to naught. There's your x equals -1. Okay, that's what we got when we divided through by x. Okay, but also what we did miss was that x could also be equal to 0, because 0 squared plus 0 is 0. Okay, and actually the same thing happens here. Okay, so if you divide through by sine x, okay, you're left with cos x plus 1 is equal to 0, and then cos x equals -1, but you've missed out that solution. So this is the special case. It doesn't look as much as a quadratic because we don't see the squared as when we saw it at GCSE, but it is a quadratic nonetheless, and we must solve by factorising. So I'm going to factorise it and take out sine x, and when I take out sine x, I end up with that, don't I? Sine x times cos x is sine cos x, sine x cos x, and sine x times 1 is plus sine x. Now that gives me sine x equals 0 and cos x is equal to -1, and we would have missed this one here. This cos x equals -1, there's my cos at -1, only one value, where x is equal to 180 degrees. Okay, that's one solution, and that would have been the only solution that we've got. But sine x equals 0 happens at 3 places. Okay, it happens at 0 degrees, 180 degrees, okay, and 360 degrees. All right, so we would have got that, but we wouldn't have got these two here. Okay, so you have to be really careful there. All right. Okay, I hope that sort of helps, that video. Look out for this. There is one of those. It's in disguise in the exercise 10F from the Pearson book, but I will pick on that one in my supplementary video to this that is just going through some of those questions. Okay, but have a go at exercise 10F now. and I'm wishing you a happy Easter. Okay. Thanks, guys. Well done.